Good evening. This is still part of Lecture 1, Section 3.2. I'm going to cover some of the example problems for compound interest, for continuous compound interest, and I'm going to use the logarithm rules. And we're going to be using the DocCam to do this. So let's get started. The first problem that we're going to take a look at is problem number 10, an example problem. And these are all in the book. These are all in the book, so we're going to be doing problem number 10, which is this right here. Using equation number 4, and equation number 4 is A equals P times 1 plus I to the n. Find the future value of P equals 2800, I equals 0.003, and n equals 24. It's really a very, very straightforward application. The future value is A, so A equals, and we're just going to enter the values right away, 2800 times 1 plus 0.003 to the 24th. Actually, it looks like I've got a little bit of a typo here. Let me fix this right away. So it looks like we've got a typo right here. So let me just kind of, cross this off. And this should be to the 24th. Okay. And you should be able to calculate that using your calculator and get that answer. This is actually more calculator practice than anything else. You should be getting these answers. You should be comfortable using your calculator. Your calculator is your friend. Get used to it. Let's take a look at problem 38C. So here the question is, if 2,000 is invested at 7% compounded monthly, what is the amount after 5 years? And then, how much interest is earned? Well, the first part is we're going to be, because we're given compounded monthly and 5 years, we're going to be using equation number 5. And so let's just make a note of that. So that's A equals P times 1 plus R over M to the MT. We can probably pretty much just plug the values straight in. So 2,000 times 1 plus R over M, 7% is 0.07. Compounded monthly, there are 12 months in a year, so M is 12. M is 12, and for how many years? For 5 years. Times 5. Once again, this is figuring out how to use your calculator appropriately. If you do that, you should end up quite clear. You should end up with the answer that is given here. Practice using your calculator. If you're not getting this answer, try and try again. Then the question is, how much interest is earned? Well, the interest is the amount minus the principal. That's how much interest was earned. So again, a fairly straightforward calculation. So 2835.19 minus 2,000, and that gives us 835.19 in dollars. And we'll correct this one, so 2835.19. Sorry, make it in the right position there. Just going to make a quick change. I'm going to adjust this just a little bit. Okay. Okay. There we go. Okay, now we're going to take a look at continuous compound interest. So this is where it's continuously compounding. We're going to use equation number 6. This is problem number 16. Equation number 6 is A equals PERT. Find the present value of. So present value, that is our principal. That's P. So let's solve this equation for P. So basically, we have P equals A divided by e to the RT, and that equals P. I just divided it by that. And then we plug in our values of 19, e to the RT. R is 7.69, so that's 0.0769 times 5. Using your calculator, you should end up with the results that we're showing below. Of 12,935 and 0.3. If you're not getting those values from your calculator, practice until you are. You need to be comfortable using your calculator. So it's going to be critical to succeed in this class. Now we're going to do some that require using logarithm rules. We're going to do problem number 57. Get a new piece of paper out. And the reason these require using the logarithm rules is because we're asking for a t. So how long will it take for $6,000 to grow to $8,600 if it's invested at 9.6% compounded continuously? So we use the same equation as we did last time, which is A equals P e to the RT. Only now we're solving for t. In order to do that, we divide both sides by p, and then we take the log of both sides, so the natural log of both sides, and then we take a look at what some of our rules were. So the first thing we do is we apply let me change colors here. We're going to apply the power rule to this side of the equation. So we have RT, ln of E. And then we're going to apply the identity rule. So this equals RT. Are we okay with that so far? Good. Now, t is simple. So we're still solving for t. So now, t is equal to 1 over r. We're dividing both sides by r, ln of A divided by P. Okay? And we should be seeing that result here. Using the values that were given, 8,600, 6,000, and divided by 0.096. We should end up using your calculator correctly. This should be about, it's not going to be exactly, but it's about 3.75 years. Now, one of the tricks with this, and we'll see it a little bit in the next problem, is if we want to say how long does it take for this money to double or triple, we just create a ratio here, right at this point right here. So if we want to say how long does it take for money to double, it would be A over P is equal to 2. That means we doubled our money. And we're going to use that trick in the next problem, number 62A. How long will it take money to double if it's invested at 8% compounded semi-annually? So semi-annually, so we have to use the other compounding formula. So the compounding that we're using, it's not continuously compounding. And recall the formula is A equals P, 1 plus R over M divided by M, MT. Semi-annually, well, let's work this all out. So let's divide both sides by P. So we end up with A over P, and that equals 1 plus R divided by M, MT. Now, earlier I mentioned we want this to double, so we basically are setting this ratio, A over P, equal to 2. So this equals 2, right? Now, we take the log of both sides. Taking the log of both sides, we have log of 1 plus R over M, MT equals log of 2. Again, we're going to use the power rule like we did in the previous problem. We're going to use the power rule like we did in the previous problem. So we're going to have MT log of 1 plus R divided by M. Okay. We're going to divide both sides by this. So we have MT equals log of 2 divided by log of 1 plus R over M. And then T. We want to know the value of T. So let's solve for T. Divide both sides by M, and we end up with 1 over M log of 2 divided by log of 1 plus R over M. Now, we plug in the values, the numbers that we have, that we were given. And those are, the rate is 0.08, and that goes R. Can't quite see that, sorry. There we go. So the rate is 0.08, and that goes R. The compounding period semi-annually, so there's 2 periods in a year, so M is equal to 2, and that goes here and here. We already have log of 2, so everything else is just a calculation. Now, I recommend doing this in smaller steps. So write this down, and then solve what you have inside your parentheses. And then calculate the logs, and then divide that by 2. And you'll end up with 8.836 years. If you're not comfortable with your calculator, practice with it, get far more comfortable with it. You should be able to do these calculations for the most part without error. The trick is setting up the problem and then solving it. See you next time.